All right, as we start day 3 here, let's look at the bell ringer. The first thing I'm going to address, though, is for graphing. Number 1, how do you graph, number 1, a piecewise function in Desmos? It's not going to be typing in these symbols just like they did. It won't work that way. How do you have to change it? Do you remember? You do use the squiggly, but not right there. Where do we use it instead? Where that comma is. So you won't type it in there. The way you will graph this one is you will do the squigglies here and here. One more note before I let you work on your own graphing these. Number 1, I only see, well, I'm not going to tell you until I get through 2, 3, and 4. What are you not allowed to do in division? Divide by 0. If you graph these, they will show you how many breaks each one of those have, and not only how many, but where they're located. I'll give you a hint. Since the power is 2 in the denominator, each one of these two, excuse me, each number 2, number 3, number 4, each will have 2 discontinuities. Make sure you will have 2 discontinuities. Number 1 will not have 2 discontinuities. Piecewise will create 1, but there's nothing else to create a discontinuity. So this will only have 1, but these will have 2 answers each. Make sure you get a total of 7 answers on this bell ringer. So now you can pause and go off and work on your own. So now I have mine typed in. So let's take a look and see what observations we can make on the first one. On the first one, I graphed these 2 pieces, and I graphed it like we said we should. Remember, piecewise, how you take away the f of x equals squiggly on the left, and you do this on Desmos as 2 separate lines. So I've done that. What can you tell me about this graph? That would be a jump, and you could track down to the x-axis to find out what the x value is. You need to say the jump at and list the x value as well. So that would be number 1. If for some reason you didn't know if it was open circle or closed circle, I want you to know you can click the graph and drag it. You see how this top piece has a closed circle? The bottom piece would have a open circle. In case you're needing to match a graph or something like that, I want you to know you can use that tool as well on Desmos. So that would be number 1. Okay, number 2, I'm going to graph this and return home. As I mentioned a second ago, what are you not allowed to divide by? 0. You're not allowed to divide by 0. So if you're not very good at looking at this saying, where are my breaks? You could graph the denominator. If you graph the denominator alone, this would indicate to you where you'll have breaks because the denominator is not allowed to equal 0. We could see that those are the 2 breaks, -3 and 3. And so then you go back and look at your graph and say, what's happening at -3 and 3? What type of breaks are those? And you don't have to call it out. I'm just showing you. So this would be number 2. You could try that on your own. Number 3, again, I can see 1 break. But if I were like, hey, I want to make sure I got all of them, if you copy the denominator and paste it, you can see, wait a minute, this graph actually has 2 breaks. It has a break at -2 and another at +2. So -2 and 2. Now I'll take away the denominator and looking at this graph, okay, what's happening at 2? And then I decide what's happening at -2. You can click and drag like that. And you can figure out what's happening at -2 as well by using Desmos in that matter. Finally, one more time, I'll graph, here's number 4. I've graphed it. I see 1 break readily, but if I wanted to make sure I got all of them, I can copy the denominator and paste it. The denominator says there's actually going to be 2 breaks. There is this break at 0, but there should be another one at +2. So I'll take away the denominator and I look what's happening at +2. I can drag my graph over, and now I've found all my discontinuities. So I just want you to be aware that you can do that to solve for your answers. Well, now let's get started. So pick up in your packet. We are going to start on number 26. Number 26 now. So number 26, it says this: an arithmetic series is shown 3 plus 8 plus ... plus 33 plus 38. Which of the following summations accurately describe this series? And you have 3 different options here. All right, and so we're looking at these 3 series, and we have to determine which one is accurate to represent the series given above. This is really easy to do if you can remember the process of sigma. How does the process of sigma actually work? Like, what does the calculator do if it tried to solve for sigma? It does find the sum. So let's go over. I'll type in answer choice A. Can someone else, if you're in the back side of the classroom, can you type in number 2? And if you're in the front of the classroom, type in number 3. And we'll see what our values are. I'll do number 1. You do the back and do number 2. Someone else do number 3 in the front. I say someone else, go ahead. A lot of people.
You say front to what?
Number 3. Let's see what value you get. I'm going to do sum of number 1. So SUM. This is a K. K is 3 to 10. And I'm getting 5K minus 12. I'm getting 164. Now, students in the back of the classroom, I asked you to find sum for number 2. What did y'all get for number 2? Okay, what about anybody in the front for number 3? 162. Okay, in the back, anyone for number 2? 160? Check. I don't think it's 116. Check all your values. 164. Okay, so let me just give you a little casual test taking strategy. If you were to type in all 3 of these like this, you could eliminate an answer. For certainly could eliminate 1 for sure, maybe even 2. Here's what I mean by that. Number 1 says 164, no, 2 says 164, 3 says 162. I look at answer choice D. D is saying, remember the instructions, which of the following summations accurately describe the series? D is saying 2 and 3 are correct. Could both of these be correct at the same time? Could the answer be 164 and 162 at the same time? No, so D is certainly out. And you could probably throw out which other one? C is saying 1 and 2 are true. That very likely could be true. B is saying only this one's true. That could be possible. A could probably be thrown out. Why would you say A could probably be thrown out? You would think if you're getting the same answers, they're probably the same. So we can probably throw out A, but I'll leave it just in case. Here's the process of sigma. You take the lower bound, and what do you do with the lower bound? You plug it in. So what I'm going to do here is for number 1 or series 1, I'm going to plug in the 3. So A1 would equal, you plug in a 3, 5 times 3 minus 12. Help me out. What is 5 times 3? 15. When you subtract 12, you get 3. Is that what you're supposed to have? Yes, that's good. Now, before I continue on, I want to see if I can eliminate anything else. I'm now going to try sigma number 2. Not sigma number 2, series number 2 here. Let's try this one. A1 would equal, and you take your lower bound and you plug it in. What's 5 times 0? Plus 3? 3. Is that what it's supposed to equal? Yes, it's supposed to be 3. Now let's try the third. The third series shown to us. When I plug that one in, I'm taking my lower bound and I plug it in. What is 5 times 0? 5 times 0 is 0, but then I subtract 2. Am I supposed to have -2? No. So we pretty well can estimate that we have the answer. Now that we know that 3 is not possible, we can go ahead and assume the answer is going to be C because the first 2 are matching up. Let's just check it to make sure. Both number 1 and number 2 are saying that this is going to increase. If you think of like y equals mx plus b, this is saying these are increasing by 5 at a time. It's kind of like the slope. Are these increasing 5 at a time? Is that what's happening? Yes or no? Are they increasing by 5 at a time? Yes. So these are both the same. Since they gave us the same first value, they gave us the same A1, they're both increasing by 5, and they gave us the same total. That will be the same. So the answer would be C. We could have thrown that out, like we said at the very start, because they were the same number. Questions over sigma. I've got another sigma problem for you. Number 27 says this: Holly is trying to solve the summation given there using a formula. Okay, I'm going to pause here and show you on the formula chart. I don't usually use these other formulas on sequences and series. I tell you just to use these top two or the binomial theorem. That's what I tell students all the time. Just worry about these. Don't worry about the other formulas. It's just extra stuff you got to try to keep track of. Just pay attention to these. Well, this formula right here is on there. It's this one right there. But I don't usually use that one. Anyways, that's what it's used. That's where it's coming from, if you're wondering. It says here, Holly substitutes the value n equals 4, a1 is negative 68, and an equals negative 104 to discover the sum. What can be determined about her work? Now in your packet, it says on answer choice A that her work's incorrect. N does not equal 4. B says her work is incorrect. A1 does not equal negative 68. C says her work is incorrect. AN does not equal negative 104. Finally, D says her work is correct. The sum does equal negative 344. Here's what I suggest. I want you to first go to Desmos, type in this value and see what you come up with. You do it on your own, and then you're going to call out to me what you get. All right, countdown. What answer did you get? 5, 4, 3, 2, 1. Negative 430. Okay, if that's the true sum, if the true sum is negative 430, did she do her work correctly? No, so D is wrong. That's not the sum. The true sum is negative 430. So D is out because her sum is incorrect. So now it's either she had to have made a mistake with one of these values. So I'm going to walk you through how you find the different values. First off, the easiest is probably A1. We just did this on the last problem. How do you find your first term?
Is the first number?
You plug in that lower bound. I'm going to use the vocabulary here. You plug in the lower bound. So if I plug in the lower bound, ignore the sigma. I'm no longer paying attention to the sum. I'm trying to find an individual term. What I will do is just plug in the lower bound. So it'd be 13 minus 9 times 9. Can you go to your calculators and type that in and see what you get? All right, 3, 2, 1. What are you getting? Negative 68. All right, did she make a mistake here? No, it does equal negative 68, and this says does not equal, so B is wrong. Symbols don't match up. Okay, so now I'm going to skip down to C. C says the last term. That's what AN can mean, the last term. It can mean any term. A lot of times it's used to mean the last term. So on this, how would I find the last term?
13.
You plug in the upper bound. So I'll just plug in the upper bound. Since I'm not paying attention to the sum right now, just a term, I'm going to ignore the sigma and just say 13 minus 9 times 13. Now I bet a lot of you already typed that in. 3, 2, 1. Negative 104. Is that correct?
Yes.
I mean, she says it does not equal. We say does equal. This is not the right answer. The symbols don't match up. So the answer must be A. What's another way, or what does the N refer to? Here's what the idea is. N is the number of K values. So how many individual K values do we have? Let's count and see. K could equal 9. What else could K equal? 10. What else? 11, 12, 13. How many different K values is that? 5. N equals 5 because there's 5 unique K values. So that is not the correct answer. N equals 5. So A would be the correct answer. By the way, if you're wondering, you're like, well, I don't get it because 13 minus 9 is 4. The problem here is that would be taking away the K value of 9. That would be taking away if you did a subtraction. Are we supposed to take away 9? No, it's included. So really you're taking away the first 8 values. So it's 13 minus 8 is another way of thinking about it, which would be 5. All right. So there is your review on sigma. With that, I'm going to give you a DOL. I went easy on you because these two problems were harder. So now I'm going easy on you. I'm just going to ask you, what is that sum? Your DOL is just to find out what is that sum. All right, pause video if you need more time. I'm moving on. let's now look at 28. So back up here, the first 27 problems we looked at, since bell ringer on day 1, have not used the formula chart. We just haven't used it. I told you that's one of the 5 types of problems, and then we just haven't seen it since bell ringer number 1 on day 1. Here we are. It says a theater has 38 rows of seats. The 4th row has 37 seats. The 5th row has 41 seats. The 6th row has 45 seats, and so on. What is the total number of seats in the theater? We are now getting into the thick of sequences and series, and we're going to use this formula chart. So what I'm going to do here first is anytime you realize you're dealing with a sequence or series, I want you to know that we're going to use one of the top 2 formulas. We're either going to use the nth term of the arithmetic or the nth term of the geometric. I'm going to copy them both down. I'm going to copy both of these down on here, and then we'll determine which one of the 2 we're using. Okay, so can someone read off to me what the arithmetic formula is? Mark, do you mind taking out your headphones for me, please? Okay. The nth term, what does that say for the arithmetic? An equals A1 plus N minus 1. There's the arithmetic formula. Okay. Now, what's the geometric formula? Equals A1. Perfect. Those are our 2 formulas. Now, the first one, arithmetic, deals with if the series is being added or subtracted by a certain amount. The second one, that's why it's a plus here. The second one's if it's being multiplied or divided by a certain amount. That's why they're next to each other, indicating multiplication. So on this one, it says the 4th row, so A4 is 37. The 5th row has 41. The 6th row is 45. What is happening each time? Are we adding, subtracting, multiplying, or dividing? We're adding. How much are we adding by? 4. That's what you call your common difference. Each time we are adding 4. We are adding 4 each time from one spot to the next. That's called the common difference. So that is going to be the formula with the plus. So I can eliminate the geometric formula. This is arithmetic. And so we'll start plugging in our values. Before one more question. It says, what is the total number of seats? What's a synonym for total? Sum. We're doing sum. Do you remember what sum replaces? Sum is sigma. But what does it replace in the formula? AN equals. There. Don't forget about the equals. Yeah, take all that out. So sigma itself comes with the equal sign. So you take that one away. Anytime you write by hand, put a n equals 1 at the bottom. And I'm going to put a parenthesis around this whole thing. All right. According to the data, what is our A1? That's not A1 though. That's actually A4. Can we use A4?
Yes.
Yes, but if you change this to A4, and minus 4, that's right. So A4 is 37 plus, anytime you use sigma, don't replace the n. So it's going to be n minus 4 times our common difference of 4. Now the question is, we are adding up rows. How many rows are there? That's the 4th row, 5th row, 6th row. How many rows are there? 38 right here. There's 38 rows. So that would go there. I'm going to pause this. I'll let you find the value yourself. All right, question I had come in. If I'm changing this A1 to an A4 and this n minus 1 to a 4, don't I change the sum to a 4? The answer is no. Whenever you're writing a sigma by hand, this will always stay at 1. It doesn't matter. This is just what's needed here is to say that that is not the first row. So when it calculates, the n minus 4 will end up helping you go back to what the actual first term is. So this one will stay here because they are rows all the way from row 1 to 38. But it's these 2 that change. So it's only those 2, not this one. That'll stay in equals 1. All right, give me your answer in 5, 4, 3, 2, and 1. 3,762 is what I'm hearing. That's I think it's this number. I don't think it's 75. So we're checking from n equals 1 to 38. And our equation was 37 plus n minus 4 times a 4 on the outside. Yeah, 3,762. Check to make sure you put a 4 there. That'll be required to get the right answer. Okay. All right. Let's take a look at number 29. So a sequence is given by A1, comma, A2, comma, 25, comma, 32, 39, dot, 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 all the way up to 207. It says how many terms are in this sequence. So once again, anytime you know it's a sequence or series, what I'd recommend is you go to the formula chart and at least you don't have to copy down both. I will, but at least notice that it's going to be one of those two formulas that you're going to use, either the nth term here or the nth term over here, arithmetic or geometric. So I'm going to copy both of them down. The arithmetic was an equals a1 plus n minus 1 times d. The geometric is an equals a1 r to the power of n minus 1. Okay, so let's evaluate what type of sequence do we have. Is it arithmetic or geometric? Is it adding, subtracting, or multiplying, dividing? Which of the two?
It's adding.
It's adding. Very good, Anthony. What's it adding by every time?
7.
It's adding 7. Each time we are increasing by 7. So this is an arithmetic where our common difference is 7. This time, what are we looking for?
How many terms?
Okay, so that would be what letter? N. That's going to be our unknown. So let's just plug in. AN can mean last term. Just remember a couple symbols. AN can mean last term. It can mean any term. It can also mean the last term. That's how it's used in this case. So what is our last term?
207.
207. Our A1, do we have A1?
Yes.
No. What do we have?
We have
A3. So if I'm going to use A3, I need to change this to n minus
3.
3. So A3 is 25. Plus, we don't know what n is, so I'm going to use an x here. Minus 3 times our common difference of 7. We could do the algebra, but I know a lot of students want to make sure they know how to use the calculator. On the Desmos star, if you type it in just like that, it will not give you the answer. I know a regular star would give you a vertical line where the answer is. If you type that in, I'm doing right now, I'm going to use an X for my unknown. So you could type it in. If it were a regular, not regular star, I'm sorry, regular Desmos calculator, it would give you a vertical line indicating where the answer is. But on Desmos star version, which is what I believe the ACP will be given in, it will not give you the answer. What you need to do, if you remember, is you're going to take and say y equals the left side of the equation. How you'll graph this is you'll say y equals 207, and then y equals 25 plus x minus 3 times 7. If you graph those two, the intersection, the x value at the intersection will be the solution. So I'm going to graph those two. Y equals 207. Oops, forgot the y. Y. And I'm going to graph y equals this right side. I'm just going to copy and paste. Where the two graphs intersect will be the answer. So I'm going to zoom out till I see both values. There they are. If you click that, you'll get the answer. Let's get, what's your answer in 5, 4, 3, 2, and 1? 29 is correct. It's the x value there. So that would be the answer on this one. There are 29 terms. 29 terms is the solution. That would be the answer here. And that takes us to DOL number 2. Here's an arithmetic. And oh, wait, hang on a second. I'm going to back up. those two problems, I kind of combine in this DOL. On this first one, we went through and we solved to find how many terms. On this one, we solved for a sum. I have your DOL here, and you're gonna have to do two things. You're gonna find as you start to work this, you're gonna have to solve first to find out how many terms there are. But the first thing you're gonna have to do here is you're gonna have to find out how many terms there are. How many terms? Secondly, you're gonna have to find what is the sum of the sequence. Okay, so there's kind of a little helpful thing for you. You're gonna first need to find out how many terms are there, and then actually find out how many terms, find the sum. That's gonna be the order you need to go through to solve this problem. DOL number 2. Let's look now at number 30. Number 30 says, what is the sum of the infinite geometric series? So what's different on this problem than the previous problems? It says geometric. It tells us, hey, we're not using the arithmetic formula. This time we're using geometric. So I'll go over the formula chart. I'm going to go to the formula chart, wherever it is. There it is. And I'm going to take the geometric formula this time. I don't have to write down both. We know it's the geometric, which said AN equals A1 R to the power of, and it's about n minus 1. Okay, are there any other key words up in the instructions? I hear infinite. What's important about infinite? It's going to be 1,000. N is going to be, we're going to just say it's 1,000. I'm going to say approximately 1,000. Because infinity is not a real number. Very good. Any other keywords? Sum. Sum is a keyword. How do I find a sum from the formula? Sigma. What will sigma replace? AN equals. So this AN equals is going to disappear, and we're going to replace it with sigma, and you'll put everything else in parentheses. So anytime we write a sigma from hand, what do we put on the bottom? N equals 1. And how high is n going to count? 1,000. A1, do we have our first term? -9 over 8. Great. Now the part that people forget is how to find the R. Remember, the n minus 1 won't change. Hey, for the sake of the calculator, to get the power in, you're going to need to put the n minus 1 in parentheses. Otherwise, if you don't put in parentheses, the -1 will no longer stay as a power. It will come off to the side. So that's going to go there. How do you find your R? Do you remember? That's right. The common difference is second minus first. This one is second divided by first. And so to find that R, if you go to your calculator, I would use a parenthesis and say 3/4 like this. Divided by, so do a parenthesis around that to make sure the division works right, because it's a fraction divided by a fraction, which is weird, and you want to make sure that the calculator does this right. I would type that in like that if I were you first. So I'm going to type in first this R value, which was 3/4, and I'm dividing that by -9/8, and I'm going to change it to a fraction. By coming over here to the blue portion and pressing that white button there, -2/3. So our ratio here, our common ratio, is -2/3. That's what goes in right there. If you type that in, you should get your sum. I'll give you a minute to do so. All right, what answer are we getting in 5, 4, 3, 2, and 1? -0.675. Do me a favor, change that to a fraction. Press the button on the left, the blue, we're in the blue where the white button is, it changes to a fraction. What do you get? -27 over 40. That'll be our solution there. I'm gonna write it this way. That would be the sum. All right, that brings us to DOL number 3. I want you to do the infinite sum of this geometric series. DOL number 3. All right, now let's take a look. 31. So I'm transitioning from arithmetic and geometric, and now I want to show you something with the binomial theorem. So take a look at this formula chart at binomial theorem. And I want everybody to look at this. I need you to see something, make an observation. That binomial theorem, is that formula simple or complex? It's very complex. You don't need that whole formula. There's only two portions you could get. If I could, I would be ecstatic if I were able to print off the formula charts for you. I can't do that. It's all the same for the district, but what I wish it would show you is just a plus b to the power of n, which all of a sudden it's not letting me click it for some reason. Just this first part, and then the NCR part. That's all you need, are those two portions. So what I'm going to write down here is what you need. When you see binomial, what I want you to have is a plus b to the power of n equals, you can ignore a whole bunch of stuff until you see the NCR. It is. So it's all right there in the formula chart. And then there's more that comes after it, but you can ignore that as well. I wish we could have it just say that on the formula chart. That would be great, because that would make it simpler for you. In this problem, what represents the A? I'll get there. I'll get there. What's our A here? 3x. Now, for the calculator, I'm only going to use a 3, but I want you to know that truthfully, it is 3x. For the calculator, I'm only going to use A. That's what we called the winning value last time. The B, what is our B this time? -2. And again, technically, it's -2y, but I'm going to skip that for a moment. What's our power of n? How many times do we play the game? 8. Okay, so once you identify those values, here's how we'll type this in the calculator. You will type in n as a lowercase, c as a capital, n as a lowercase, and then 3 parentheses. The first parenthesis is going to represent the NCR. The second parenthesis, the A. The third parenthesis is the B. So I'm going to plug in what we already know. What is our n value? 8. Now, truthfully, the C stands for the word combination, but mental technique time. I want you to think of n comma r. So put a comma there. So just think of n comma, and then the r will go there. Well, we don't know what r is yet, so I'm going to move on. Do we know what a is? Because that's what, according to the formula, it goes NCR followed by a. What's our a? 3. We don't know what r is, so I can't establish the power yet. Do we know what b is? -2. That's right. So all we have to find out is what's r and our n minus r. So how do we do this? Think of gambling. If you go out to gamble 8 times, what's the best case scenario for you? You win 8 times. So the first term would be winning 8 times, losing none. That would be the first term. The second term would be winning how many times? Second best situation is win 7, lose once. Okay, what's the third best situation?
6.
Win 6, lose twice. And finally, for us, the fourth term. What's the fourth best situation? Win 5, lose 3. That tells you your powers. I'm winning 5, I'm losing 3. Now, the formula chart tells you to use the losing value as your R. I don't like to be a loser. I like winning, so I'm going to put the 5. It doesn't matter. You can use either number, and it'll give you the right answer, but that's what you type in the calculator. I'll let you do so. Make sure you use a capital C, but a lowercase for the N and the R. Type all that in, see what you get. It's occurred to me, I haven't typed any of these in a long time. I'm going to come over here. N, capital C, R, 3 parentheses, 8 comma 5, 3 to the power of 5, and -2 to the power of 3. I'm getting -108,864. Is that the value y'all are getting? All right. -108,864. 864. Now, because it says the fourth term, and by the way, that's why I stopped here at 84. Because it said the fourth term, I would include, it did not say coefficient, but fourth term, I would include the x to the fifth, x to the fifth, and the y to the third, because technically speaking, A was 3x and B was -2y. So technically this should have an x and y, but that's just not what we typed in the calculator. You don't include it in the calculator, but you would in the answer. That's why it's x to the fifth, y cubed. This would be our solution right here. So let's go through this one more time. 32. What's the coefficient of the x to the fifth, y to the fifth term in this expansion? This time they've helped us out. So again, from the formula chart, what's the important parts of the binomial theorem? A plus b to the power of n. And then the NCR portion. That's the important part right there. What's our A this time around? My A is, for the calculator, 1. What's our B? -2. What's 10? Sorry. N is 10. So when we type this in the calculator, it'll be NCR, followed by our 3 parentheses. The first is the NCR, the second is the A, the third is the B. So N we know is 10. What did I say the C stands for? Not technically, but what do I want you to think of? Comma. So 10 comma. I'll skip the R for a moment. A is 1, B is -2. Now up here, you know what that's telling you? That's your R values. You could use either one of those for R. So it's 5 and 5 since they're the same number. Get that. I'll let you type that in and tell me the answer. All right, 5, 4, 3, 2, and 1. -8064. 8064. This one says only coefficient, so that would be the answer right there. They only want the coefficient, they don't want the term, so it would just be the numerical value, not the x to the fifth, y to the fifth. All right, your turn. Go ahead and try DOL number 4. DOL number 4. All right, now we're transitioning to real world problems. So I've done a ton of all kinds of random problems. Now we're going to get into real world problems. It says here the annual growth rate for an investment is found using this function, where R is the annual growth rate, T is time in years, P0 is the initial investment, and P is the present value. 5 years ago, I'm going to stop there. 5 years ago, where does that go? What is that? That would be an element of time. So T is 5. 5 years ago, Helen invested $5,000. Okay, what is that 5,000? If it's 5 years ago, that would be the original or the present value? Original, so P0. And an annual growth rate of 3.7%. What's that going to be? R is 3.7%, or we could say that is also the same thing as 3.7 divided by 100. What is the present value? That's what we're looking for. Present value, that is the capital P. That's what we're looking for. So what I would suggest we use is the calculator, just because it doesn't make algebra errors. What do we know our rate is? 3.7. We're going to divide that by 100. So 3.7% is the same thing as 3.7 divided by 100. We'll set that equal to 1 over, what's our T? 5. What's ln stand for? Natural log. We don't know present value. What I'm going to do here is put an x over P0, which is 5,000. And I'll just install this, but when we install, it with Desmos star, we don't just type it in like that. It won't give us an answer. How will we have to type this in? Do you remember from earlier today? Y equals. So we're gonna have to change it to where it's y equals the front, and then also y equals the back. We'll have to do it like that. So we'll have to type in those to get our solution. So go to Desmos here. Y equals 3.7 divided by 100. And then we're also going to have y equals 1/5 natural log. I'm going to use an x over 5,000. And so I'm looking for the intersection, which is kind of hard to find. My guess is it's bigger than 5,000. So I'm going to zoom out and see if there's anything to help me out. Oh, there it is. I started clicking and I saw these two decimals come up. That's my guess of where the answer is. So let me zoom in on that. Let's see if I zoom in, if that's the actual intersection between these two graphs. It looks like that might be the intersection between the two graphs. I lost it. What happened? There it is. I'm getting $6,016.92.092. Is that what you are getting? This is a very tricky one without that vertical line to help us. So that one might have been easier if you did use a little algebra, but it seemed to me that when I zoomed out, when I started clicking around and then I got those two answers, you could edit, by the way. So look at my screen for a second. If you go up to the graph settings, you could change it saying, okay, I realize this is really close to the y-axis to where your x's are still zoomed out like they are, like mine are. But I'm going to change this to like -1 and +1. And it makes it easier to see where the intersection is. I don't know if you saw what I did. I did graph settings. Just because this R value was so small, I just changed it to where the Y was not zoomed out, but the X was zoomed out. And there I got the exact answer. So there's a little technology for you. So P is roughly, since this is money, we're going to round it to the nearest cent. How much money was it? 6,016. So 0.92, would that be 10 cents or 9 cents? 9 cents. That's our solution there. All right, let me give you number 34. It says Brent, dealing with blood disorder diabetes, must closely monitor his blood sugar. After eating a meal, the blood sugar or the rise of his blood sugar can be modeled by this equation, where T is time in hours. So T is time. T is time. Oh, and I should have said blood sugar is S of T. If the blood sugar needs to remain at a level of 80 milligrams or greater. Okay, that's telling me a value. Blood sugar needs to be 80 or greater. About how much time can I wait to eat another meal? Where does the 80 go if it's blood sugar? S of T. So we're going to say that S of T here is 80. And honestly, this is supposed to be 80 is greater than or equal to. But I don't know if Desmos will cooperate the same way, or I don't know exactly how to do it. I can play around with it. But either way, I'm going to separate this as y equals 80. And then y equals all of this over here. I'm going to do y equals all of that over there. So let's go do this problem. I'm going to zoom home here to get it ready. Y equals 80. And then y equals -7. I'm not going to use t's. I'm going to use x's. X to the power 4 plus 124x to the power of 3 minus 320 x to the power of 2 minus 1600x minus 1600. And then finally, it's all over t squared minus 8t t squared minus 8. No, minus 8x. I'm going to change this to x. X minus 20. So I don't see anything. I'm going to zoom out a little bit here. Oh, there we go. I'm seeing some vertical lines. I'm going to zoom out. Okay. For real world problems, remind me, for real world problems, where do we look for our solutions? It's got to be in the first quadrant. So I'm going to use, now that you know how to do restrictions, I'm going to eliminate some of the negatives by doing this squiggly and say, okay, X has got to be greater than or equal to 0. That'll eliminate some of the negative side to make this easier. And also my Y's have to be positive as well. It's got to be a real world first quadrant. So Y has got to be greater than or equal to 0. I'll add both of those. Well, that's not working. So never mind, I won't add that one. So anyways, here it is. So my blood sugar needs to be at or above 80, which means it's above from here, but not down there. So this problem ends at this time. So my answer is going to be somewhere in here. Now let's look back at what I'm supposed to find. What's the question? How much time can I wait to eat another meal? What would the answer be? If this is my blood sugar, I'm fine because it's above, it's above, it's above. This is where I need to eat by. My answer would be 7.283. That's correct. 7.283. I can wait 7.283. And I think this is in hours. Time in hours. Yes. 283 hours. And that would be the answer here. All right, and now let's look at a couple more, and we're kind of running out of time. I'm going to go as quickly as possible here. The idea the rest of the way is the same. It's going to be to end solve here. So it says the formula to calculate the level of sound intensity in decibels is given here, where B is the number of decibels, I is the sound intensity, and watts squared per square meter of any sound, and I0, the initial, is given here. Okay, the question is, what is the pain threshold of the ear? The pain threshold for the human ear is 120 decibels. Now that's the dB, and if you remember from up here, decibels is the B. So that means right here we have 120. It says, what's the intensity I of this sound given I0 right here, or the initial I? So this would be 10 to the power of -12. And so when I type this in, what I'm going to do is Y equals 120 and Y equals 10 times log. And instead of I, I'll put an X. That's our unknown. I is our unknown. Divided by 10 to the -12. Okay, so that's what I'm going to type in. We'll see what you come up with here. So I'll clear that out. I'm going to go home. Y equals 120. Which indicates these are going to intersect at the height of 120. And then Y equals 10 log X divided by 10 to the power of -12. Okay, I'm going to zoom out to 120. There it is. And that should be my solution. My solution looks like it's 1. When I look down here, though, I don't see the answer of 1 anywhere. So notice that how all these have 10 to the power of something. So they're saying 10 to the power of something has to equal 1. So there's two ways I can go about this. I could, one, change this to 10 to the power of X. And now my answer says, oh, the power has to be a 0. And so you can see the answer is C. Or you could type in these answers and see which one equaled 1. And I'll do that now. 10 to the power of 0, you'll see is 1. And so if I left this the way we originally did it, you'd see that that would be the solution there, 1. All right, let's do another one. Here's 36. The population of a small town is modeled here, where N is the number of years. In 2004, the population was 45,000. So that's like an old number, not our current number. If the annual rate of increase was 7.5%, which equation determines the number of years it takes to double the population? Okay, double the population means my population is no longer 45,000, it's doubled. So 45,000 times 2 would equal 90,000. And so that's going to be P of N, if you will, P of N. So we don't know how many years, that should be lowercase, sorry. So let's go to our formula, and what we're saying is this is 90,000. This right here is 45,000. The rate here, if the rate is 7.5%, remember that's the same thing as 7.5 divided by 100. That will go there. 7.5 divided by 100. And the xn is the unknown. And so what I'm going to do is y equals 90,000 and y equals 45,000 times 1 plus 7.5 divided by 100 to the power of x. And we're going to see what we come up with here. It's a new problem. I'm going to clear all this off. And we have y equals 90,000. So we can see that this value will be really high up. I could have simplified the problem by dividing both sides by 45,000. That would have canceled out here, made this a 2, but it is what it is. Type this in. 1 plus 7.5 divided by 100 raised to the power of x. I'll zoom out, and we need to go up to 90,000 to see both graphs. There they are. My solution is going to be, it looks like 9.584. Approximately. So if the n is 584 or 584. Let me change that to 584 years. And I don't know how to round it, or what to round it to, but that would be the answer there. All right, and now number 37. Newton's law of cooling models the temperature, T, of an object over time, little t, in minutes. So temperature is a capital T, little t is minutes or time. Using this function, okay, where T0 is the initial temperature of an object, Tm is the surrounding medium, and K is the constant for a particular medium. A cookie was taken from the oven and placed in a cooling rack with a surrounding air temperature of 20 degrees. Keyword here, surrounding air temperature. So what does that mean? The surrounding, notice that word surrounding here. This is Tm. So we know Tm is 20. After 5 minutes, that's a time. So little t is 5. The cookie cooled to 48 degrees. So this is the temperature after 5 minutes. After 5 minutes. So that means it's T of 5 or T of T here. Temperature after time would be 48. If K is 0.35, let's go plug that in. There, that would be 0.35. What was the temperature, T0, the initial temperature of the cookie? So that's our unknown. So how we graph this is y equals 48 and y equals 20 plus the initial temperature is what we're looking for. T0 is our unknown. So I want to do an x there for that, minus 20 times e to the power of negative 0.35 times 5. Let's see what we get when we solve this one. So again, I'm going to clear everything, take it home. We'll type these equations in. Y equaled 48 and y equals 20. Again, if I wanted to simplify, I could subtract 20 from both of these, but it is what it is. I'm going to type it in like I've already done. E to the power of, nope, wrong button, power of negative 0.35. Let me see if it'll let me multiply by 5. It won't. So I need to do it by a parenthesis here. Parenthesis times 5. And I see that that messed up. There we go. So there's my first graph. We're going to zoom out until we find the second graph here. There it is. The initial temperature was 181.129. Initial temperature is approximately 181.129 degrees Celsius. That would be our answer. Make sure I copied that right. Yeah, I did. All right, we got one more before your last DOL here. The Texas Department of Public Safety collected data on stopping distances for a number of different types of cars. They found that one brand stopping distance could be modeled by that equation there. where y is stopping distance, and I'm going to hit this here. Y is stopping distance in feet, and x the speed of car in miles per hour. The car required 100 feet to stop. Okay, so if it's a stopping distance, we're looking at a y value. So y is 100. What is approximate speed just before the beginning of the brake? So I can solve this. Again, anytime you have a formula with values, you can plug these in and solve, just separating them at the equal sign. And we'll type these in and see what we come up with. Y equals 100, that's the 100 feet to stop. And our equation okay, we'll zoom out until we find our solutions. Now remember, real world, you don't take the negative answer, you only take the positive. The positive answer is 42.6, and this is in miles per hour. So x is the speed in the car, miles per hour, and which was approximately 42.6 mph, and that would be our solution here. So now your problem, I know in your packets, I did not write it full sentences just for sake of space, but it's the same problem, but I've changed it now. And we're now looking at a vehicle that doesn't take 100 feet to stop. What if it takes 200 feet to stop? What would be its approximate speed just before the beginning to brake? You can pause the video, and that's a wrap for day 3.